So hello everyone, my name is Mintian from class AI and Robot from Phenica University. Today I'm going to present my project on human pose estimation, which is a part of the advanced deep learning course under the guidance of teacher Lê Minh Huy. So this presentation will cover the motivation behind choosing this topic, the dataset that I used, the method that I implemented, and finally the result and conclusion from the experiment. So let's go to the table of content. As you can see here, my presentation is contained in three main sections. The first is introduction, where I will explain why I selected this topic and give detail about the dataset. The second is method, where I describe architecture that I design in test. So the third one is result and conclusion, where I present evaluation metric and summarize the finding as well as the limitation and future direction. So let's come to the first part. There are several reasons why I chose this topic. So in the human world, there are increasingly important application for this. For example, in surveillance system, it can help detect the suspicious behavior. In healthcare, it can assist patient monitoring or elderly care by recognizing activity like walking or falling. And in sport, it is useful for analyzing the athlete's movement. So let's go to the dataset. For this work, I use the NTU dataset, which is one of the largest and most widely used dataset for human action recognition. The dataset provides skeleton pose data extracted from video frame. So here are some in solution. On the left, you can see that a number RGB frame of a person performing an action. So on the right, you can see the exact skeleton represented only by joint and line, like a stickman. So the dataset is organized into training, validation. It contains a large number of action class covering most of the daily activity such as walking, running, or standing up. This dataset is particularly challenging because of the wide variety of action and different body movement input, which makes it suitable for testing deep learning approach. So for the method, I implement and compare two approach. The first is LSTM with fully connected layers. So here, instead of connecting directly to the output, I add four fully connected layers after the LSTM. The idea is to give the model more representational power, allowing it to learn complex patterns before making the final classification. And the next one I use is LSTM plus linear. In this model, a two-layer LSTM processes the sequence of skeleton frame, and the final hidden state is directly connected to a single linear output layer that predicted the class. This is a simple Bayesian architecture. So let's look at the result. I evaluate the model using confusion matrix. We show the number correct and incorrect prediction for each class. This will visualize allow us to identify which action are recognized well and which action is often misclassed. As you can see, the action most of the action is very good at both model, except for the first one is standing up. It's often confused with running or just walking. So when we look at the training and validation curve for the results, so that the LSTM with the fully connected layer is outperform the linear model. It achieved a higher F1 score and so fewer errors in the confusion matrix. So for the conclusion, to conclude, we can say that Adding more fully connected layers after the LSTM improved the overall performance for skeleton-based action recognition. It's clearly that the fully connected layer is outperforming the linear baseline when it's coming on the serial action. For the future work, there are several directions. First, I will try applying the model using real-time camera input. The second is incorporating attention mechanism or transformer architecture to capture temporal dependence. And finally, to exploring the multi-channel input combining RGB video and skeleton data both at once, which could further improve the recognition performance. So that's the end of my presentation. Thank you for your attention. If you have any question, I'm happy to take it. Just DM to my email. Thank you for listening.